So today we are solving a question which came in IOQM 2025-2026 of number theory. What is the question? The sum of two real numbers is a positive integer n and the sum of their squares is n plus 1012. So we have to find the maximum possible value of n. So at first, we are assuming that the two real numbers are x and y. So let the numbers be x and y. So satisfying the conditions given in the question, we can write that the sum of the numbers is n. So x plus y is equal to n, and our second condition is sum of squares. So x square plus y square, which is equal to n plus 1012. So in the second equation, we can use the formula of a square plus b square. So x square plus y square can be written as x plus y whole square minus 2xy, which is equal to n plus 1012. Substituting the value of x plus y, which is n, we get n square minus 2xy is equal to n plus 1012. From this equation we get xy, that means product of real numbers, is n square minus n minus 1012 divided by 2. So we have to construct now a quadratic equation whose roots are x and y. Consider the equation whose roots are x and y. The equation must be a quadratic equation because there are two roots x and y. So the equation is a square minus sum of roots multiplied by variable a plus product of roots, which is equal to 0. If x and y are the roots of a quadratic equation, then the equation can be expressed as a square minus sum of roots into a plus product of roots, which is equal to 0. Now substituting the values, x plus y is n. So we get na plus value of xy is n square minus n minus 1012 whole divided by 2, which is equal to 0. So multiplying throughout by 2, we get the equation as 2a square minus 2n multiplied by a plus n square minus n minus 1012 equals to 0. So the quadratic equation whose roots are x and y is given by 2a square minus 2na plus n square minus n minus 1012, which is equal to 0. But we have to satisfy now the original condition given in the question. What is that? The roots of this equation x and y are real numbers. 0. So since the roots x and y are real according to question, so discriminant must be greater than or equal to 0. What is the formula of discriminant? B square minus 4ac. So here b is the coefficient of a minus 2n whole square minus 4 into a is coefficient of square term, that is 2, and c is the quadratic expression n square minus n minus 1012, that means constant term. Now calculate and simplify. 4n square minus 8n square plus 8n plus 8096 greater than or equals to 0. So this equation can be written as minus 4n square plus 8n plus 8096 greater than or equal to 0. Minus 4 is common. So n square minus 2n minus 2024 within bracket greater equals to 0. So the final quadratic expression we get n square minus 2n minus 2024 less than or equal to 0. Now we have to factorize that expression. So n square plus 44n minus 46n minus 2024 less than or equal to 0. So the complete factorization is n plus 44 multiplied by n minus 46 less than or equal to 0. Now we have to find the solution set of this quadratic inequality. We can see that value of the left hand side is 0 when n is minus 44 and also when n is 46. So just point out these numbers minus 44 and 46. So it is clear that when the value of n is less than minus 44, the expression is positive. In the next region, expression is negative, and the final region expression is positive. And we have less than or equal to 0, that means we have to consider the region where value of the quadratic expression is negative. That means we have to consider this region. So we can say n is an integer belonging to -44 to +46, where it is given that n is a positive integer. If n is a positive integer, then the possible values of n are 1, 2, 3, and so on up to 46. Therefore, maximum possible value of n is 46.